Assalamu alaikum. Today we want to talk about chapter 15, amines, entitled amines. First section, 15.1 amines. These are different amine compounds starting from ammonia on H3, then a primary amine called ethylamine, and then a secondary amine, diethylamine, and a tertiary amine, triethylamine. Then we have here a cyclic amine and this compound called pyrrolidine. Then amines, generally speaking, they are classified as primary, like this, secondary, like this, or tertiary amine, like this, according to how many organic groups are individually bound directly to the nitrogen atom. If one group is bound, 1R, this is primary, 2R, secondary, 3R, tertiary. The R group can be alkyl or aryl, aromatic. So here the R group is an alkyl group, and here the R group is called aryl group. Each amine nitrogen atom has a lone pair of electrons. This lone pair is responsible in large part for the chemistry of amines. When a fourth group bonds to the nitrogen through this lone pair, the product is a quaternary ammonium ion, as you can see here, which has a permanent positive charge and forms ionic compounds. Then this is called a quaternary ammonium ion, and it can form ionic compounds, as we will see. Now, primary alkyl amines are named by identifying the alkyl group attached to nitrogen and adding the suffix amine to the alkyl group name. Some examples of naming primary amines here. So here we have two carbons here. This is ethylamine, one word. Ethylamine, one word, no spaces. This alkyl group is called isopropyl. So this is isopropylamine. Now, this is a cyclohexyl amine. So all of these are classified as primary amines. Simple secondary and tertiary amines are named by adding di or tri to the alkyl group name along with the suffix amine. Some examples of naming simple secondary and tertiary amines here. Here we have two propyl groups, so this is called dipropylamine. Here we have three ethyl groups, so we have triethylamine. Now, this one is a secondary amine, this one is a tertiary amine. When the R group and secondary or tertiary amines are different, the compounds are named as N-substituted derivatives of a primary amine. The parent compound is the one that contains the largest of the R groups. All other groups are considered to be N-substituents. Some examples of naming more complex secondary and tertiary amines are here. How many substituents we have? Now, what is the longest hydrocarbon here? 1, 2, 3 carbon. This is the longest. So this is the main. So this the parent compound is the one that contains. So propylamine is the parent compound. All other groups now are considered to be N-substituents. So here we put N-ethyl for this propylamine. So this is an example of a complex secondary amine. Then again, the parent amine is the one with the largest of the R groups. Propylamine is the parent. So this one is designated as N-ethyl propylamine, one word. Now again, in this case, the propylamine is the parent one, but here we have two substituents. So we put N, N dash, and we have dimethyl propylamine. Now this is a complex tertiary amine. So we have a complex secondary amine and a complex tertiary amine. Notice here we put in for the substituents. Now the lone electron pair on the nitrogen in amines causes amines to act as weak Bronsted-Lowry bases or simply Lewis bases. What is a Lewis base? Is a compound containing an unshared pair of electrons. Like here, if we have, this is ammonia. When we dissolve ammonia in water, now this is a Lewis base because it has this lone pair on the nitrogen, make this a Lewis base. Then it can accept a proton here to form this ammonium ion. Also in this case, if it can react with an HCl to form this compound. Here plus OH minus, here plus Cl minus. So the proton is added to here in both cases, and the lone pair of electrons is used to generate a new covalent bond here and here, and the plus is added to the nitrogen atom. Primary and secondary amines can hydrogen bond with one another. Because of hydrogen bonding, primary and secondary amines have higher boiling points than alkanes of similar size. Oxygen can form more hydrogen bonds per molecule than nitrogen. Alcohols have even higher boiling point. So if we compare these three, an alkane, butane, propylamine, and propanol, which one has the highest boiling point? Of course, the alcohol, propanol 97 degree, then propylamine 48, then butane has a 0 boiling point. Notice here we have the molecular weight is almost similar, 58, 59, 60. Remember this if you are asked to arrange these in order of increasing or decreasing boiling point. All amines can form hydrogen bonds with water. Amines with up to about 6 carbon atoms have appreciable solubility in water. Then all amines can form hydrogen bonds with water. Remember this. In many nitrogen containing compounds, the nitrogen atom is in a ring with carbon atoms. Compounds that contain atoms other than carbon in the ring are known as heterocycles. Now, heterocyclic nitrogen compounds may be non-aromatic or aromatic. For example, here piperidine, which is a saturated cyclic amine, and pyridine is an aromatic amine. So this is non-aromatic, this is aromatic. And in this table, here are some heterocyclic nitrogen compounds. Look at them and know the difference between them. Purine, pyrimidine, indole, quinoline, pyridine, imidazole, pyrrolidine, and piperidine. Now, basicity of amines. Aqueous solution of amines are weakly basic. If you take this amine, react with water, forms OH minus, but it is in equilibrium. Whether we have primary, secondary, or tertiary amine, all of them in water, they are the solutions are weakly basic. Now, an ammonium ion is a positive ion formed by addition of hydrogen to an amine. Now, Alkyl amine cations are named by replacing the ending amine with ammonium. So here we have, this is ethyl ammonium ion from ethylamine, ethyl ammonium ion. This is dipropyl ammonium ion. So because of the presence of this positive charge on this nitrogen, this is if you remove a proton from here, then we will have this called dipropylamine. But when you add the proton here, it becomes dipropyl ammonium ion. And also this one is called pyridinium ion from pyridine. In general, non-aromatic amines are slightly stronger bases than ammonia, and aromatic amines are weaker bases than ammonia. So this is the order. Know this order: non-aromatic amines more than ammonia, and ammonia more than aromatic amine. So these are stronger than ammonia, and ammonia are stronger bases than aromatic amines. Now, ammonium salt is an ionic compound composed of an ammonium cation and an anion, an amine salt. Now, they are named by combining the ion names. For example, NH4Cl is ammonium chloride. Ammonium chloride, an ionic compound or a salt. Ammonium salts are generally odorless, white crystalline solids that are much more soluble than neutral amines. So if you have, for example, this is tertiary amine, tributylamine, water insoluble plus HCl, it becomes tributyl ammonium chloride. This is water soluble. So you can dissolve this tributylamine in HCl to form a water soluble tributyl ammonium chloride. By this system, methyl ammonium chloride is written in this way. So how we name this? Methyl ammonium ion. Methyl ammonium ion. If a free amine is needed, it is easily regenerated by treatment with a base. Quaternary ammonium ions have 4 organic groups bonded to the nitrogen atom, giving the nitrogen a positive charge. With no hydrogen atom and no lone pair, ammonium ions are neither acidic nor basic, and their structures in solution are unaffected by changes in pH. Their salts are known as quaternary ammonium salts. Like this. Then, this is benzalkonium ion chloride, an antiseptic and disinfectant, are here equal this to this. This is called an amine salt. And this ends this chapter. Thank you.